Hello math students. For math today you are going to need a math notebook, a math workbook, your pencil and eraser, and I'd also like you to get a math board and a dry erase marker and a tissue or some kind of eraser for that. If you need to go gather those materials, pause the presentation and I'll see you back here in a sec. So this is lesson 1-7 and it's called Add Unlike Fractions. By the end of this lesson you will be able to add fractions with unlike denominators. And if you listen really well and try your best on this one, then lesson 1-8 will be a breeze because you do the exact same steps for lesson 1-8 at subtracting unlike fractions. So as a quick warm-up, I would like you to write equivalent fractions for each fraction shown below. Use your blank side of your math board. Remember that there are specific steps to write equivalent fractions. If you are unsimplifying, then you multiply both the top and the bottom by the same number. And if you are simplifying, then you divide both the top and the bottom by the same number. So go ahead and write equivalent fractions now. When you're done, resume the presentation and we can compare our equivalent fractions. Maybe we'll come up with some of the same ones. Okay, now that you've had a chance to try the warm-up out, I'm going to go ahead and write equivalent fractions for 3/5. Remember, I can choose any multiplier I want. I cannot do a divisor here because there is nothing other than 1 that I could divide both of these numbers by. And if I divided them both by 1, I'd end up with 3/5, which isn't an equivalent fraction, it's the same fraction. So I'm going to choose 3/5. I'm going to choose a divisor of 4. When I multiply the numerator, I get 12. The denominator, I get 20. 12/20 is equivalent to 3/5. For 7/10, I think I'll choose a multiplier of 3. Again, I can't do a divisor because the only common factor they share, 7 and 10, is 1. So if I multiply by 3, I end up with 21/30. This number, the multiplier that I'm choosing, can be any number in the world, just as long as you multiply both the top and the bottom by that number. For 2/9, I'm going to choose a multiplier of 10, which gives me 20/90, equivalent to 2/9. And for 10/20, since this is the first one that I can actually divide, I am going to go ahead and choose a divisor here. I am going to choose 5. 10 divided by 5 is 2, and 20 divided by 5 is 4. So one equivalent fraction to 10/20 is 2/4. So now to the main point of this lesson, adding fractions that do not have common denominators. The example shown here is 1/2 plus 1/3. I'd like you to take a second and using the fraction bar side of your math board, try to figure out what the sum of 1/2 is. 1/2 plus 1/3 is. Instead of taking volunteers, stop and talk to the people that you're working with and see if you can come up with any reasonable way to add 1/2 and 1/3. But please be careful. 1/2 plus 1/3 is not 2/5. We do not add denominators together when we're adding fractions. When you have had a chance to talk with the people around you, come back to the presentation and resume it when you're ready. So I hope that you at least had some practice trying to add those two fractions, and maybe you were able to come up with something, maybe you weren't. Let's take a look at this example so that we can get into how we would go about adding unlike fractions. Erin mixed 1/3 of a cup of orange juice with 1/4 of a cup of pineapple juice. What total amount does she have? What information, which is just the numbers, do we have in the problem? No, we have 1/3 of a cup and 1/4 of a cup. I'll circle that. What is the question? What total amount does she have? What operation should we use? Well, since we want to know the total amount, I am going to use addition. We have 2 parts. When we have 2 parts, to find the missing total, we add. So the equation that we're going to solve is 1/3 plus 1/4. To add two fractions, they have to be parts of the same whole. Are these fractions parts of the same whole? Well, I have 1/3, which is one of 3 equal parts, and I've got 1/4, which is one of 4 equal parts. Since 3 and 4 are not the same, and those denominators tell us how many equal parts are in the same whole, the answer to that is no, these are not part of the same whole. To add two fractions with different denominators, you could use the math boards. If we circle 1/3 on the bar and 1/4 on the bar, we've got two separate fractions, but now the question is, okay, well, I can't combine them because they are not the same size parts, so what do we do? What we have to consider is how could we divide both fourths and thirds into the same size unit fractions? If we split the fourths and the thirds into twelfths, then while we have a different amount of thirds and a different amount of fourths, now they are the exact same size pieces. Twelfths becomes a common denominator. We're using a common unit fraction so that these two fractions can be added. Before adding or subtracting fractions, you must find a common denominator. How many twelfths is 1/3? Well, I see what is circled. My thirds are still 1, 2, 3 thirds. But we split each of those thirds to make a total of twelfths. How many twelfths is 1/3? Well, that would be 4 twelfths. We did a similar thing to the fourths. We still have 1, 2, 3 fourths, but each fourth was 3 split. So 1/4 is equal to 3 twelfths. Now that you know how many twelfths both of these fractions are equivalent to, we can add 4 twelfths plus 3 twelfths, which equals 7 twelfths, to find the sum of 1/3 and 1/4. Here is an example of putting those two equivalent fractions together on the same fraction bar. Now that they are the same size pieces, they're all twelfths, you can see that adding 4 twelfths with 3 twelfths is just putting them next to each other for a total of 7 twelfths. On page 17 of your workbook today, when you get to it, you are going to rename fractions using a fraction bar model. We did this similar thing in lesson 1-4. So if you need to look back at 1-4 to help you with these models, that is completely fine. When I rewrite fractions with common denominators, though, I use a quicker and easier method. I find common denominators by asking myself 3 different questions. The first question is one a factor of the other? The second question, if one is a factor of the other, then you simply use the larger denominator as the common denominator. The second question I ask, if that is not the case, do they share a factor other than 1? If they do, then I'll list out the multiples. If they don't, then the last method that I will use is the product of the denominators. Be very careful. 1/2 plus 1/3 is not 2/5. We do not ever just add the top and then add the bottom. That is not how we add fractions. Here's why. Find 2/5 on your fraction math board right now. Is it more or less than 1/2? Let me do a quick drawing of 2/5. It's not a very good drawing, but we can kind of take a look at it. If I look at 2/5 and then I compare that to 1/2, you can see that the half is greater than 2/5. So the question is it possible that you could start with 1/2, which is what our equation started with, add 1/3 more to it, and then somehow end up with a smaller amount than what we began with? It's not possible. Adding is putting more to something when we're dealing with just positive numbers, so it wouldn't make sense to end up with a smaller amount than what we began with. Remember, any number that is a multiple of both denominators can be used as a common denominator, but using a smaller denominator can make the math easier. Here's an example. We're going to add 1/6 plus 3/4. If I have the fractions 1/6 and 3/4, I'm going to start off by asking the first question. Does 4 go into 6 evenly? No, it does not. So the next question I ask is, do 4 and 6 share a common factor? And I know that they do because they're both even, so they're both divisible by 2. It doesn't really matter what that number is, but if they share a factor other than 1, then I know the best method to use is to list the least common multiples. So I'll list the multiples of 6 and 4, and the smallest one is then the best number to use for the denominator. I know the first multiple of 6 is 6, then we go to 12, then 18, and I'm going to stop there and just see if that's enough. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. As soon as I hear a number that's in both lists, I know that that is the least common multiple, and that is what I'll use for my common denominator. So I start with my two little equal signs, and I set up the new fractions, the equivalent fractions, with 12s in the denominators. Ask yourself, well, what did we multiply 6 by to get 12? And that is 2. Whatever you do to the bottom, you do the same thing to the top. 1 times 2 is 2. The fraction below that, what did we multiply 4 by to get 12? And that was 3. Whatever we do to the bottom, we do to the top. 3 times 3 is 9. Now when I add 2 twelfths plus 9 twelfths, I get a total of 11 twelfths. Let's look at using 24 as a denominator. I've got the same fractions, 1/6 plus 3/4. Let's say I went straight to product of the denominators because it's easy to figure out what that is. The denominators are 6 and 4. 6 and 4. So I know that 6 times 4 is 24. So I could use that as a common denominator. After all, the rule is we just have to have a common denominator to add. We multiply 6 times 4 to get 24, so we'd do the same thing to the top, and we end up with 4 24ths. The fraction on the bottom, we multiply 4 times 6 to get 24, so we do the same thing to the top. 3 times 6 is 18. When we add those, we end up with 4 plus 18, which is 22, all over 24. Here lies the problem. 22 24ths, those are both even numbers, so that I know that I can simplify those. And we should always give our answers in simplest form. I know they're both divisible by 2, so I'll start there. 22 divided by 2 is 11. 24 divided by 2 is 12. I got the same answer as I did for the first example, except I had to take the extra step to simplify this fraction. So I will always ask myself those 3 questions before I add fractions to make sure that I am avoiding simplifying as often as possible. Sometimes you will still have to simplify, but usually you can avoid it. So we're going to do 3 examples here. 7/16 plus 1/4 is the first one. When I am adding any fractions, I know that I have to have a common denominator. Ask yourself the 3 questions that are the exact same questions you asked when we did the lesson on writing equivalent fractions. The first question to ask yourself is, does the smaller denominator go into the larger denominator evenly? In this case, the answer is yes. So that's really good because this is the one that gives us the least amount of work. If the answer to that question is yes, then all you have to know is you use the larger of those 2 denominators as your common denominator. If 16 was the original denominator and the new denominator, then that basically means we're multiplying by 1, and the numerator will not change either. That's what makes this one nice, is you really have half of the work to do. On the bottom, in order to go from 4 to 16, we multiply by 4, so I'd do the same thing to that numerator, and we end up with 4/16. 7/16 plus 4/16 is 11/16. I'm trying to erase, but my eraser doesn't want to work. Okay, for some reason it's not going to let me erase that part, so I'll just leave that. All right, let's try the next one. 2/9 plus 1/6. Remember that there are 3 questions to ask yourself. The first question, does 6 go into 9 evenly? The answer to that is no. So I can't just use 9 as the common denominator. The second question to ask yourself is, do they share a factor other than 1? I know that they do because both 9 and 6 can be divided by 3. What that factor is really doesn't matter. It just tells me that I should list out the multiples to find the least common denominator. So I'm going to come down here to the bottom because I'm running out of room, and I'm going to list the multiples of 9 and 6. I know the first multiple of 9 is 9. 9 times 2 is 18. Now I know that I'm going to be listing the multiples of 6, and since I know my basic facts, I also know that 18 is a multiple of 6. So at this point, I really don't need to list the multiples of 6, but I will just to show you as well. Remember, memorizing those basic facts will make your life in math a lot easier from here on out. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. There's my 18, and that's my common denominator. What did we multiply 9 by to get 18? The answer to that is 2, so I will multiply the top by 2 where we get 4. What did we multiply 6 by to get 18? That was 3, so we do the same thing to the top, and 1 times 3 is 3. Now when we add 4/18 plus 3/18, we get 7/18. 2/9 plus 1/6 is 7/18. And I'm going to try and erase this. There we go. Still not letting me erase that black part. Okay. So for our last one, we've got 1/3 plus 7/12. First thing I know, they do not have common denominators, so I need to find a common denominator before I add them together. First question is, does 3 go into 12 evenly? The answer is yes, it does. So that means that 12, the larger of those 2 numbers, is the common denominator. On this bottom fraction, 7/12 was the original fraction. If 12 is still the new fraction, then 7 must be the numerator. On the top fraction though, what did we multiply 3 by to get 12? That's a 4, so we do the same thing to the top. 1 times 4 is 4, so when we add these we get 11/12. When you ask yourself those 3 questions, you end up doing the least amount of work, whether that's in the beginning or not having to simplify. Make sure that you include in your notes the exact same anchor chart that we used in the lesson on equivalent fractions so that you can use that to help you find common denominators for adding. Make sure you ask for help if you need it, and good luck.